All right, so we're going to talk about lines. We're going to talk about circles. So if you remember in your extra credit project, there was a section of circles that you hadn't learned those words yet. We're going to learn them the next few days. We're going to talk about special segments and lines. Can anybody tell me what a segment looked like?
It's got 2 dots.
2 dots?
Connecting with a line.
That's it. How did we name, let's say this was, sure, A, B. How would we name this? A line with no dots and A and B. Is it the same thing as BA?
No. Yes.
No.
Yes, it is. Yes, it is. The only one that wasn't was array.
Oh, yeah, that's right.
Just array. This is not array. You won't see them. So then the next one we're talking about is lines. What did a line look like?
It's a dot with an array.
That's array. Nope.
A line is just a line.
A line that doesn't end.
Yeah.
If we had a CD, we would say CD, and what would the line above look like?
Arrows.
It would have arrows. Is CD the same thing as DC?
Yes.
Yes, it is. Again, the only thing where you can't switch is the arrays, and we're not seeing those in this section. All right, then we're going to talk about tangents. Okay?
Awesome.
So first thing we want to talk about is a circle, how to name a circle. I would write it somewhere random or on the front of the notes. A circle is a set of all points in a plane that's equidistant from the center. So you name a circle by its center. So this one would be called circle P. Or you could write it as a circle and then a P. So I would write down, these are the 2 ways to name a circle. Either with the word circle and then the center letter, or draw a circle and then the center letter. We do see circle K sometimes. Y'all know what circle K is?
It's a dead bird. It's a dead store.
Wait, no. I have one.
It's a gas station.
I have one next to my house.
That's great.
I know what she's talking about.
A dead store?
I thought you were talking about Kmart.
Yeah.
Oh, no, Circle K, like the gas station.
Yeah, kangaroo was way better.
I didn't know. I did not know that. I guess that makes sense.
Yeah, Miss Morgan.
Whatever.
Yeah.
Congratulations for knowing about gas stations. Next. Nothing. So we're going to talk about different types of lines and segments. So you want to leave room around here because we're going to talk about them. If you like to use different colors on your notes, this would be the time. Your picture's going to pop up or look the same. So you want to label each piece. We got a radius. So it should not be a new word, so you should be labeling this circle right here at the top. You do need to know the difference between all of them. So we got a radius. Where does a radius go from? The center to the outer. Yeah, center to the edge is what I call it. But this is the official definition. A segment whose endpoints are the center and any point on the circle. Can you have more than one radius? Yes, you can. All right, next one is a chord. What does it look like a chord is?
It looks like it doesn't touch the center.
It goes from edge to edge, but it can touch the center. When it does touch the center, that is called a diameter. So a chord is a segment whose endpoints are on the edge of the circle. Diameter is a chord that contains the center of the circle. So are all chords diameters? No. Are all diameters a chord? Yes, they are. By definition. Can you comprehend that? Okay, you look like you were thinking about it. So all 3 of these are called segments. I would make sure you know that they're all 3 segments. So I'd write that down. So you can name it correctly because it won't be correct if you don't. So I'd write that these are all segments because we're about to talk about lines. The people that mostly struggle with this are of the male.
Yes.
Well, that's racist. That's pretty weird.
Not.
Racist. That's pretty
So think about this. Think about in real life. Girls pay more attention to detail. Are we correct?
Which girl?
Yeah, what girl?
All of them.
Which ones? They,
Girls are usually better at this because
I disagree.
I'm gonna
it's
just
fine.
prove you wrong.
You prove them. Prove me wrong. There you go.
I'm wrong.
Right there. You're not hurting me by proving me wrong. So.
Just get a 0 and prove it.
All right. Well, there you go.
Hey,
That's the second solution. You
Not
do.
my mind.
You do you. We're going to talk about the lines. All right, so the first one is a secant. So go ahead and label your secant on your circle. Secant. You'll actually hear this word again in Algebra 2, not in geometry.
Wow.
You remember how I told you there are 6 trig functions, not just 3? Like we learned sine, cosine, and tangent. There are 3 others. One of them is secant. But we're not... This is just a coincidence of words. You're... How many times does a secant touch the circle? Twice. That's the exact definition. A secant touches the circle twice.
Would a chord is not the same thing as a secant?
A chord has a start and ending point. A secant extends infinitely. Good question. How many times does a tangent touch the circle? Once. Once, and it touches at the point of tangency. I'm just checking that you're doing what you're supposed to. So all of these, that was a terrible little bracket. All of these are lines. So it's a very good question from Colt, even though you thought it was dumb. I didn't think so. A secant extends infinitely. A chord has a starting and a stopping point. So these 2 are types of lines, and the top 3 are types of segments. All right, so here's how I tell people to remember the difference between a secant and a tangent line. How many times does a secant touch a circle? Twice. How many times does a tangent? Once. So I just see this visually. S and 2 look more similar, and T and 1 look similar. It's the only way that I remember. I mean, I just remember from math teacher, but I'm just telling you. Or you can just memorize it, whichever one. S and 2 look similar. Do we not agree?
I agree.
They're both squiggly. T and 1 look very similar because they're both... Well, that's fine. You figure out your own way to figure it out, buddy. Don't be dumb. All right, here we go. Number 1. We have a picture. Focus. We have a picture. Name 2 radii. Why did I call it a radii?
Because there's 2.
It's plural. Have you ever heard of a syllabi?
Yes. Or a die.
A die instead of a dice. Yeah, but that's a little different, but yes.
Come on.
Name a radii. Remember that a radii is a segment. So what is one of the radii here?
AB.
AB. Go ahead and write it. AB, which is the same thing as BA. Next one.
A chord, that would be
No, we're on a radii. We're on number 1.
ADF.
We're on number 1. We have not finished number 1.
AF.
AF. We are on number 1. AF.
There's one more, right?
Yeah, we're going to write all 3 of them.
AD.
And then AD. Yeah. Now we move on to number 2. There are actually 3 chords in this picture. A chord goes from edge to edge.
I got you. EC.
EC. And then I'm going to listen to Mackenzie. What'd you say?
ED.
EC. ED, yes. So ED with a straight line above it. DF, yes. I know, buddy, but I was in the middle of writing another one. ED? What do you mean? Number 3. Name a diameter. How many diameters are in this picture? Just the one, which is? DF. All right, name a secant. A secant is now a line.
ED.
E what?
ED.
Yes, ED. Sorry, I thought you said B.
Yes, totally.
ED. Are there any others?
B. No.
No. Name a tangent. You actually need to fix this because when you name a line, you just have 2 letters. So pick a letter. That's not A, B, C, D, E, or F.
Okay.
She said Z.
G.
So a tangent touches the line at, or touches the circle at 1 point. So what would we name this line? Nope.
Ray.
Nope.
Just B.
BZ. That's why we made up a second letter. You can't name it with 1 letter. You gotta name it with 2.
That's crazy.
What is the point of tangency? B. The point of tangency is where the tangent line touches the circle. That's it. We flip. In a plane, two circles can intersect in 2 points, 1 point or no points. Coplanar circles that intersect at 1 point are called tangent circles. So they can intersect at 2 points, so it would look like this, where they overlap. So we're not yet on that picture, so do not draw on the pictures yet. So they can intersect at 2 points, 1 point, which we would call that tangent, or no points. So we're going to talk about tangent circles in this next section. But you do need to know what concentric means. Concentric are the circles with a common center. So I ought to write that down. Concentric are circles with a common center. So circles with a common center. Circles with a common center. So we're going to talk about this section. At first, it's going to seem pretty weird to you, but afterwards it'll make more sense. I promise you'll catch on. A line or segment that is tangent to two coplanar circles is called a common tangency. So if you look, there are two black lines here. A common internal tangent intersects the segment that joins the two center circles. So which one of these lines, you got a left one or right one, which of these two lines is between the two circles? The one on the right. So this is the internal tangent because it's sandwiched between the two circles. What other better way to say it? And then the external is on the outside of both of them, not between them. So in this section, we're going to talk about internal and external. So you will catch on, I promise. Tell how many common tangents the circles have and draw them. So here's what will happen. A tangent, how many times does a tangent line touch a circle? Once. So I'm just showing you, do not draw this yet. Will this line that I have drawn ever touch the other circle? No. So this would not be a tangent line they have in common. We need to find a tangent line that they have in common. We're going to do the external first. What if I put a dot here? If I drew a straight line, would it ever touch the other circle? Yes, it would. So once. And if you draw it correctly. So here's one external tangent. We can't draw one, not yet, between, because we're talking about external tangents. Can we draw one on the bottom as well? Yes, we can.
Can I draw it?
Yeah.
You said that.
Sorry, I was just saying don't draw what I'm going to show you hypotheticals and explain why we don't do those. That was all.
Are these the hypothetical?
No, these are the correct ones.
What is the
The one I drew first. You can't have a common tangent point out here because it will never touch the other circle.
So
that one was don't draw that because it wasn't true.
So don't draw that top blue one?
I'm recording. Can you not be like this? We're going to do internal tangents. If I put a dot here and went straight up and down, it wouldn't touch. But what if I put one towards the bottom? Yeah. All right, could I do one at the top of it as well? Yeah. Yes, I could. I told you you'd catch on. It's not difficult. It's crazy, yes. On letter B, how many external tangents are there? External. External are 2, yeah. And internal. How many times do these circles touch? Once. So they're going to have an internal tangent touch through that one place. Letter C, how many external are there? 2 of them still. Now this is where we pause. This is actually finished, this last one. How many times do the circles touch? Twice. How many times do tangent lines touch a circle? Once. So don't draw this. If I drew a line through here, someone's still going to draw it. How many times would this line touch both circles? Twice. So that would be a secant, not a tangent. So there are no internal, just the 2 external. All right, so in our next section, it's pretty much the same thing. Tell how many common tangents they have. So in number 7, how many tangents are they going to have? 2 of them, and where are they going to be? top and the bottom.
Right here.
So top and the bottom. So tell whether each common tangent is internal or external.
External.
They're both external.
You gotta confuse first two.
Who's confused?
So
About what?
Here.
How do I help you?
just keep going.
Okay.
That's definitely not gonna help.
Well, I don't do this anymore. Just we move on. A tangent line is a line that. Okay.
Touches.
So you're finding a line that touches both circles once. One time.
If it does it twice, it's cheating.
It's a secant
It's cheating.
instead of a tangent.
Yeah, that's what I'm talking about.
Let's see when you go to do the classwork. If you're still confused, I'll walk over and help you.
These vibes really.
All right, so you don't have to, this is not on your paper, but you will have to write something down. I'm going to tell you in a second. In a plane, a line is tangent to a circle if and only if that line is perpendicular to the radius of the circle at its endpoint. So here's what I want you to write down, because I'm sure you listened to all of that. A tangent line, so you should be writing this down, and the radius must be perpendicular. What does perpendicular mean?
They have to right angle.
They intersect and form 90. Must form 90, must form a right angle, must be perpendicular, whatever you want to write there. I don't know this paper is. Oh. It was due last Tuesday, so it is what it is. All right, the second thing. So this is one of the tangent properties. Once I hit next, it's going to go away, so hopefully you've written it down. The second one, this one is very, very simple. Tangent segments from a common external point are congruent. So that sounds like gibberish because not all of us are math literate. No, it is not. Which one of these?
It's not.
Which one of these is an external point?
The S.
S. P is on the inside. You're good. So tangent segments from a common external point. What are my two tangent segments? RS and TS. From a common external point, they are what? What does it say? Congruent. So that means what I just highlighted in blue, they're both going to be the same. Congruent. Not anymore. Example 3. Is ST tangent to circle P? So a tangent line and the radius had to what? Need to form 90. We haven't even done it yet. In order for a line to be tangent, the tangent line and the radius have to form 90. Which one of these lines in our picture is the radius? PT is the radius. All right, and which one of these is the tangent line in question? Says it in the directions. ST is the tangent in question. What do the tangent and the radius have to form? A 90-degree angle. So what shape does this make? A triangle. What kind?
A right triangle.
A right triangle. We need to figure out, is this a right angle? So we need to figure out if this is a right triangle by using the Pythagorean theorem. Okay, so we're connecting the dots. We want this to be a right angle. We need to check if it is, which would make this a right triangle. To figure out if it is a right triangle, we use the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. I'm going to write it down. So which one of these would be the letter C? 37, which makes these two A and B. You'll need out your, if you want, your calculators. Hopefully not to do 12 squared. I don't know what 35 squared is off the top of my head, but I do know 12 squared.
1,225.
We're not supposed to use those. We're supposed to use our 4-function calculators.
The heck? You said you take.
I believe that the next one is 1369. Yes, I'm giving her the chance to put it away before I do.
Your syllabi.
It's a right triangle.
It is, because 1369 equals 1369. So this is a right triangle. So that means TS is tangent to circle P. Yes. It is tangent because they do form a right angle. Okay, the last one Peyton will like. Go ahead and flip to number 5. Number 5. Oop. Number 5. Yep. Because example 4 I'm doing with my honors. What is my external point here? R. So remember what we learned about tangents that have the same external point. What do we know about them? They're congruent. So we set these equal. What do we do next to solve? Subtract 4. 24 equals 3x. Divide by 3 and x equals 8. That is it.